Good day students. Today let us start the next sorting technique of 4th unit, selection sort. Now let us take a quick recap of what we have seen in the last video, bubble sort. So what do you mean by bubble sort? The bubble sort will compare the two adjacent elements and swap only when they are present in the wrong order. So the swapping will be taken place only when they are placed in the wrong order, and this technique will go through the passes and we will get the sorted array. Now let us see what do you mean by selection sort. So introduction. In selection sort, we will divide the given array of elements into two subarrays. One is sorted subarray and another one is unsorted subarray. So we are going to move the given elements from unsorted subarray to the sorted subarray based on the technique we are going to use, whether we are going to sort in the descending order or in ascending order. So if we are going to sort in ascending order means we have to pull the minimum element from the unsorted subarray to the sorted subarray, and if we are going to arrange in a descending order means we are going to pick the maximum element from the unsorted subarray and put in the sorted subarray. Okay, now let us see a real-time example. So we have taken the cards example to explain the selection sort. So as you can see, these are the given cards: Jack, King, Queen, 10 Ace and As. So this from this, which is the card that holds the maximum value Ace. So we are going to sort the given cards based on the maximum value. Okay, so first we'll hold the Ace. Ace is paired. Okay, so how we are going to arrange it? First we have to pick the maximum value card from the given array, that is Ace is paired, and then we are going to swap the cards with the first element of the array, that is Jack is paired and Ace is paired will be swapped. Why? Because As is paired holds the maximum value and we are going to sort the given cards from descending order. Okay, so how the swapping takes place? Now let us see. We have to pull the Ace card down and then change the position of Jack is paired from the first to last, and then we will place the Ace is paired to the first position. This is how the swapping will be performed in 3 steps. Okay, then now we have got a one element in the sorted subarray and all the other elements are in the unsorted subarray. Okay, so As is paired is in correct sort position, others are unsorted. Now let us move to the second one. King is paired. Whether King is paired is placed on the correct position? Yes. So that will not be swapped. Okay. Next one is Queen is paired. Whether Queen is paired is placed in the correct position, that is sorted? Yes. So it will not also be moved. Next, whether 10 is placed on the correct position? No. So now we have to perform swapping to move them from the unsorted to sorted array. How? We have to pull the Jack is paired down and then move the 10 is paired to the last position and then place the Jack is paired in the correct position. Okay. So now we have sorted the first 4 elements: Ace is paired, King is paired, Queen is paired and Jack is paired. So they are in the correct sort position and 10 is paired is in the unsorted position. So now we can see when we have 5 elements and the 4 elements are in the sorted position. I mean corrected position means the remaining one will also be in the corrected position, right? Because we have 5 elements, 4 unsorted means the 5th one also will be sorted. So we will take the 10 is paired from the unsorted array to sorted array, and now we have got the corrected sorted elements of the given cards in the descending order. Have you understood? Now see, this is the sorted array technique. We will now divide the given array into sorted and unsorted elements. This is for the ascending order. So the minimum element of the unsorted array will be moved through the wall to the sorted array. This is the basic mechanism of selection sort. So let us see a problem example. See, 77, 33, 44, 11, 88, 22, 66, 55 are the given array of elements. Now we are going to sort these given elements in an ascending order. Okay, so what are the main mechanism? That we have to take the minimum element from the unsorted array and put it in the sorted array. Okay, so let us see how we are going to do it. Now we are constructed a table where passes and the position, array position have been given: A of 1, A of 2, A of 3, etc. up to A of 8. So in first pass, K is equal to 1 given, right? The K is equal to 1 indicates the pass number. So K is equal to 1 means first pass. Then location is equal to 4. This location is equal to 4 indicates the minimum position of the given array. Sorry, minimum value position of the given array. So in the given array, what is the minimum value? 11. So the position of 11 is A of 4, that is 4. So the 4 is given as the location. Understood? So then, now what are the mechanism we have to do? We have to take the 11 from the unsorted array and we have to shift it to the first position, right? So because first pass, so first position we have to shift it. So in the second pass, 11 is shifted and the wall is moved to 33. So now it has been differentiated into a sorted array. 11 is in the sorted array and all the other elements are in unsorted array. The blue ring indicates the starting position of the unsorted array. Understood? The red indicates the minimum value of the unsorted position. Now, in the second array, k is equal to 2 means second pass, location is equal to 6. Because in the unsorted array, 22 is the next minimum element and the position is 6. So, location is equal to 6 and we have to shift the 22 to 33 position. Okay. Like that, we have to shift the minimum element from the unsorted array to the sorted array. If the elements are in the corrected position means there is no need to shift. Okay. See, now in 77, 66 in the last pass, k is equal to 7, location is equal to 4. A of 7 is 78, 78, right? So 88 in the correct position, we no need to swap anything because all the elements are in the correct position and no shift is needed. So at last we will get the sorted element of the given array. This is the problem solving. Okay. Now it is the algorithm. So what we have the algorithm? First we have to set the minimum element, that variable element as 0, then search the minimum element in the list and then swap the value with the location minimum to the first position. Then increment the minimum position to next element and we have to repeat them until the given element is sorted. This is the problem. The algorithm is then now given in the programming style. So first we have to declare the minimum position. 2 for loop is needed in order to traverse the given array. For I is equal to 0, j is equal to I plus 1 because we are going to do check from the next array, right? So if the 11 is the minimum position means we have to check from the next array. So I is equal to j is equal to I plus 1. We have to check the given element is less than because we are doing in ascending order, right? So we have to check a of j is less than a of min index. So in a of min index we will place the minimum element and we will check with the every element. If it is less means we will swap. So the swapping is done with the temporary variable. Okay. So next, time complexity. So in the worst case here also the outer loop will be executed n minus 1 and in inner loop means n minus I minus 1. Why n minus I minus 1? Because the second for loop will start from j is equal to I plus 1, right? So the last position will be 1 minus. So the n minus 1 plus n minus 2 etc. will give big O of n square. So all the worst case, best case and average case will lead to big O of n square. Since the selection sort is an in-place sorting algorithm. What do you mean by in-place? In-place means internal sorting. Internal sorting means all the sorting will be taken place in the main memory itself and no external memory is needed. So it's an in-place sorting algorithm. It will take only the constant value of big O of one space. A single space is enough for it. Advantages: it is easy to write, right? Because the minimum value have to be checked and it have to shift from one array to another array, sub array. And it can be done in place. In place, internal sorting algorithm can be done on linked list too. Linked list means in data structure it is one of the data structure where the elements can be stored. Disadvantage: since it take everything for best case, worst case at n square, it is difficult for us to execute for more number of inputs. So the more number of inputs means it will take more number of time and it will end in huge amount of time as a result. So it is one of the disadvantage in here. What is the real-time application is, there is a website called education portal called K12. In K12 education portal, the pupils, the pupils means the listed, the pupil enrolled into the education portal are sorted based on the selection sort only. They are sorting alphabetically, they are sorting in K12 education portal. If you want, you can check in the website. Okay, now let us see the next sorting algorithm. We will see in the next class.